so we're going to take an area, just like we started before. Let's say this is our area. This is what it looks like. Maybe it looks like this. So it's almost like the last one we did with the little bow tie. Okay? And then what we're going to do is we're going to rotate this shaded area. We're going to rotate it about this axis, which in this case is the x-axis, and it's going to create a solid. That makes sense. Okay? So that's what we're going to do. The disk method is when the volume is created by rotating the area about an axis. Okay? All right, let's look at this. This is tilted.
So you're basically, like with the disk method, you're basically making a section.
Yes, yes you are.
The other side, you're like one.
Yes.
Okay.
So this is your area in here. And again, we created the cone-ish thing by rotating it about the x-axis again. Okay? It just, I mean, it's like that those goofy. Let's see if I can find it. You know those goofy I don't know. But those decorations. Oh, the values, they're flat, you rotate them around, and you now have a solid. It's that kind of deal. I have some around here also. Okay. This is different because this is not created by rotation, so we'll skip that one. This one, again, here's your original area. This is a, curve. We have a boundary here, we have a boundary here. We take this area and we revolve it around the X and it creates that same look. Okay? This right here is rotated here. This is the same piece right here as right there. And it rotates. Now that creates kind of a bowl-ish like thing. So this isn't really a disc either because it's got a slight indentation. On the disc, all of your slices are going to be the same. Y'all know what a disc is? What is it? What would you? A circle. Yes, it's like a flat circle. In our case, they're going to be flat. Yes. Okay. Here's your original figure. And this time we took this area and where did we rotate it? Around the y-axis. Okay. All right, this is not a disc, and this is not a disc. Here is the original area. This is not going to be a disc either because there's going to be an openness there. For a disc, what you're going to do is you're going to take these three right here that are all discs, and what you're going to do is you're going to separate, and you're going to create this right here is a, and here's creating the solid by the rotation, okay? All right, and then what we're going to do, and I'll come back here, we're going to do, and we're going to separate it into cylinders, which are our discs. It's an app. No. Yeah, so that's what we have the original area. Now, I don't expect you to draw the 3D areas. It would be helpful if you could envision them, but if you can't, you can still do it. Okay? These are pretty easy to envision. First of all, let's match the graph, 1, 2, 3, with the solid that it created once you rotate it. Okay, so where does this one, this your, you've got probably this going on. I don't know. Which am I? Which one? The middle, that's right. This one, you rotate it about this, and it creates this kind of bowl, flat bowl on the side there. Okay? What about this one? The first one. So this piece right here is right here. So your original area probably was this, and then you rotated it about the X. So those match, so then we know this.
You basically look at the line and see which side.
Yes. Okay. So those two match. All right. So you've got this is the words, but basically we're going to take slice our solid into vertical sections and approximate each section with a right cylinder. Cylinder and a disc. This is from geometry. This is a cylinder, right? How do you find the volume of a cylinder? Whoops. Area of the base times the height. Cylinder. Pi, r squared is the area of the base times the height. Good job. Okay, so that's what we're going to go for. Remember on our area we did length times width because those were rectangles. Now we're doing pi r squared because we're doing circles. All right. Okay. So this little demonstration is nice, but remember the discs are very flat and small. It's like almost like a thing of CDs. Well, a disc is a cylinder.
Okay, that's my thought.
Yeah, a disc is a flat cylinder. All right. Okay, so this same idea, we're going to take this and we're going to cut it into this. Volume of the disc, of course, is pi r squared h. Now, h, remember they're all sitting like this. This is not an excellent picture, but they're all going to sit like this. So you're looking at like a circle, like almost like a CD, but with no hole in it. And you're lining them up, and they're all like that. They're different sizes. Okay, let me see if okay, so here's f of x equals radical of sine of x. Okay, and this is when we rotate it about the x-axis, we create this look. Okay? Yep. All right, so this is f of x equals radical sine of x. Okay? So this is what you would, create using your calculator like before when we were doing area. And you're saying, all right, now what you need to know is that the radius of the disc or the cylinder, just FYI, some people spell disc with a C, some people spell with a K. Anything goes, either goes, I should say. The radius of the disc is from the axis of rotation to the edge of the area from before. Okay? Because I seriously doubt that most of us are going to draw this. It's just nice to be able to picture, oh yeah, that makes that. Okay? Now, I said from, but more specifically, it should be perpendicular. So I'm going to draw a radius right here. That's my radius. Okay, it should be perpendicular to the axis of rotation. All right. Now, we're going to do the same top to bottom thing, or right to left, whatever it is. In this case, what is this? If I draw this radius in here, what's it going to be in terms of x or y? Yes, it's the same reason that we did before. If it eventually touches the x-axis when you extend it, or, it may just be sitting right there on the x, it's in terms of x. If it goes the other direction, it's in terms of y. So that doesn't change. But what does change from area is that we have to make a decision based on the axis of rotation, not on, oh, my boundaries are this way or this way. Okay? So that's very specific, is that it needs to be perpendicular to the axis of rotation. All right, so let's start with volume pi r squared h. Now, h is, in this case, change of x. That's just the depth, your little cylinder that you're looking at That's how narrow it is. That's the height of the cylinder. I can't.
So is it like 2 of the radius?
No, it's 1.
Okay.
It's the height right there. Okay. What's my radius? What is this? In terms of this, top is radical sine of x, and bottom is, what's the bottom x? 0. Bottom formula. Okay, so radical sine of x minus 0 is just radical sine of x. Don't forget your squared.
Would the minus 0 be inside the radical or outside?
Outside. Okay. Okay, so now you put that into an integration. Because the next thing you do is you're going to put all those little discs and slam them as close as you can so there's no space in between them. We have, you know, as we approach infinity of how many we can slam in there. Okay? Picture this, you've got little tiny discs going this way all the way through. These are smaller over here, they get bigger, and they get smaller back down over there. Yes, Megan? The radius is not the area. Yeah, but that's not how we do area. The radius is the length. Remember this is your axis of rotation right here. You have a circle sitting right here. That's your disk. Terrible drawing, but your height is how wide this thing is. Because they're sitting like this. So your change in x is your height. It may be how you find the radius, the area, because it was your length before, but it's not the area. Okay. So what's my integration? Pi, I'm going to leave that outside of my integration because it's a constant. What's the radical sine of x squared? And change in x changes to dx. Okay, now all we need is our limits and we're in business. Okay, did I lose anybody? Anybody want that again?
Couldn't you just, you didn't go straight to the integration step, couldn't that be reduced to pi sine of x, change in x? So then when you integrate it, everything is something different.
Something different than what?
Than sine of x.
Pi sine of x is the same as pi sine of x. I don't understand your question.
Okay, so you have your volume is pi radical sine of x squared, change in x. Right. So that is the same thing as pi sine of x, change of x.
Right. Change of x, change to dx, because change of x is your grid.
Oh, we
haven't integrated it yet.
Yeah, that's what I'm
saying. Okay. Yes, Kathleen. The squared out radical. Okay, now we need upper and lower limits. Okay. We're using x, so we need to be along the x. What's my lowest x? Right here. 0. My highest x. What is it? Pi. Okay, and you knew that how?
On the bottom, there's pi.
Okay. So it was told to you, otherwise you'd look at a root, 0, intersection,
It's
and just
barely wedged in, like right.
Yeah. Right here. Okay, so let's find it. Let's integrate it. All right. What's my antiderivative? Negative cosine. From 0 to pi. I'm going to put my negative out here with my pi since it's a constant. I have negative pi, cosine of pi minus cosine of 0. What's cosine of pi? -1. And cosine of 0? 1. So that's -2. What's -2 times negative pi? Oops. Okay, that's your answer. Yep. Yeah, volume shouldn't be negative either, but thank you for asking, almost asking, because you shouldn't get a negative. If you get a negative, you probably have these guys either backwards, or you have this backwards from, like you did 0 minus. The square usually takes care of that anyway, so
lot of times, isn't it that the negative answer is the same as just the positive answer, except for the negative sign?
Yes, yes, that's usually.
The Riemann
Yes, yeah, because the Riemann sums evolved into integration, yes. All right, any other questions? We'll do another one here. Good, all right, let's try the next one. Okay, find the volume of the region in the first quadrant, so that's a kind of a limit there. Bounded by the axes, okay, there's more, and the parabola of 1 minus x squared. All right, solve this form of revolving about the y-axis. All right, so let's graph 1 minus x squared looks like. Up here at 1, that's a 1. First quadrant, axes. All right, so I got green and green in the first quadrant. So I took care of all that. What's my solid? I mean, what's my area that I'm going to start with, which is this. If I start out, you can see why it could be kind of confusing with area, because you start out exactly the same way. You find your area.
So if you rotated that one, would it kind of look like the thing that
So you're going to rotate it about the y-axis. So it's going to go this way, right?
Yeah.
So what's it going to look like? Yes. And I have a flat side. Just going to go like that. Okay.
How do you know it's like a oval shape?
Well, it is a closed bowl because there's, when you rotate it here, there's no space here, so that's going to be flat. And then this is flat.
So I know, but we talked about a bowl first started.
Right.
Because that one was like,
You're getting probably ahead of yourself.
It's a
Don't worry
mountain.
about it. It's, okay, go ahead and draw your radius in there, please. Just draw it. And then look. The yellow piece. The radius has to be perpendicular to the rotation of axis, which is the y-axis, people. So every one of them that I've seen so far has this, which is not correct. The y-axis is this. I must not have seen that. Do you not have that?
I did here.
I should have started over there. Good job. I was ready. That is it. Yes. All right. You got it switched here. Okay. All right. So now we have it in the right place over here. And it looks like this. Okay? So that is, it has to be perpendicular. That's my radius. Okay? Remember, we're going to do some other kind of techniques, so you have to be pretty specific, otherwise you're going to be like, oh my gosh, what is this? So be very methodical about what you're doing. Later, maybe you can take some shortcuts, but probably not. Okay, so what's my radius? Who can tell me my radius? What the length of it is, wherever I might draw it. Holly.
1 minus x.
First of all, wait, is it in terms of x or y?
Change of y.
Okay, so you just said a y, an x, so you might want to switch that. When I interrupted you, you said something about an x. Okay.
Radical y plus 1.
So this is
Radical y plus
1 minus x squared, so you're going to get it so that it's in terms of y, so you subtracted the 1.
Oh, yeah.
And then you divided the negative. And then you took the square root. Okay.
Minus.
This piece is the positive square root. Everybody look, this piece is the positive square root. This piece is the negative square root. Okay. So we want the positive one, right?
And then you did minus 0 on the last one, but I don't understand.
Was there, why is,
Okay, then yeah.
yeah.
Okay.
Okay, so radical negative y plus 1 minus 0 again. If you're up to the axis, it's minus 0. Okay, very good. All right, right, so volume I R squared H disk. I'm gonna remind myself that I got a disk. Yes, Lizzie. Because that's the bigger side. On a number line, these numbers over here are bigger than these numbers over here. And you would take 2 minus a -4 to get the distance between them. So it's always right to left. You did that when you did area too, but I just didn't have that many of them. Because we like to do X for some reason. Okay, good question. All right, so I got my pi, I got my R, so I'm just putting it in my R. When I take this, it's really another radical squared. I don't have to deal with the 0. Because that simplified is that.
And then H becomes change.
And then H becomes change in Y. Okay. All right. I'm ready for an iteration here. What's, Kathleen, what's the square root of -y plus 1 squared? Good work. Okay. This change in Y changes to dy, as the change in Y is the derivative of Y, which is what the D stands for. Let's see. We need some limits. Now we're in terms of Y. So what are my limits? Emma? 0 to 1. Very good. This is the bottom Y, and this is the top Y. Remember that point is 0, 1. This point is 0, 0. Okay? All right. Go ahead and throw it in your calculator. We'll do kind of every other one. It's not that hard. I'll do it by hand. If you'd rather do it by hand, go for it. Let's see. Okay, there's your answer. If you put it in your calculator, I would wait with the pi, and then you get an exact number. Okay, get pi over 2. Anybody not? I did it by hand, so it's not that hard. On your homework, try to do as many as you can by hand. Remember, when you put in the calculator, the y needs to be an x. That it makes it kind of weird because it's like, why doesn't that matter? It's a dummy variable once you get it set up.
If the numbers get super outlandish, then we can put them in the
Yes,
calculator.
yes.
Will that be the same like with the test?
Yes. All right. Any questions on that one? Okay, so let's try another one. Got the figure. Find the volume of the solid formed by revolving the region bordered by y equals 2 minus x squared. That's, oops, it's in blue, so I'll do it in blue here. If you all are color coding, it makes a huge difference for me anyway. The red is, remember that's y equals 1 is a horizontal line there. And we're revolving about y equals 1. Okay. So, first of all, let's shade in what the boundary is that we're going to rotate. What is it? How would you describe that area, Megan Hawk?
It's above the
Okay. All right. So this is your. Say it again.
How do you know
Because that's your boundary. Your y-axis is not a boundary, so you want to divide it there.
how come the bottom is
Well, because it's not bound. It would just go on and on and on. We couldn't find it. It has to be bounded. What's the area between the red and blue? That's what you're asking yourself. Yes, Emma.
when we're finding the radius for this, does the radius stretch off the y-axis?
Okay, first of all, the radius has to be perpendicular to y minus 1. Perpendicular to this red. Okay, so draw it in there. Try not to make it the axis, because that might be misleading you. The radius. There you go. Okay. All right. So I'm just going to draw a random one, like right here. That's my radius, perpendicular to the y equals 1. Okay? What is my radius? First of all, is it in terms of x or y? X, because if I continue it on, it's going to hit the x-axis here. So change in x. All right, so that's what we have. Emma?
Is it 2 minus x squared minus 1?
It is. Very nice. The 2 minus x squared is your blue. Your 1 is your red. So we can simplify that to be what? 1 minus x squared. Does that make sense? Top minus the bottom. 2 minus x squared is the top. 1 is the bottom. All right, good work, Emma. Okay, so volume of a disk. We're going to do the disk pi, r squared h. All right, r is 1 minus x squared. Don't forget squared. And we had to squaring. The last two examples have been changing x is our height. We're ready for an integration. 1 minus x squared squared dx. Now all you have to do is find your limits. We're in terms of x, so all the way to the x this way. Where are these points? What are those points right there? Claire? I'm guessing, probably. Where is 2 minus x squared equal to 1? Minus x squared equals negative 1. Yep, x squared equals 1. X equals plus or minus 1. Good job, Claire.
You said it equals to 1 y. Like, why did you do that?
Because I want to know where this graph, which is 2 minus x squared, is equal to this graph, which is 1. Okay. It's an intersection again.
Yeah, we did that.
Yes. It's an intersection like we did before. Okay. Now, how do we integrate this by hand? Can we just multiply it out instead of doing u substitution? Okay, what is that multiplied out?
1 minus 2x squared.
Finish it up, Katie. How about plus x squared? Multiplying 1 minus x squared times 1 minus x squared. Okay, go for it. Give you a minute, and I'll start. Antiderivative is next. Yeah. I know I have to reduce, but
I thought, yeah, I thought.
negative 4/3, yeah, 2 of everything. We could have used our symmetry since this was an even function, but we didn't. Let's see,
Do you want me to put it in my calculator and see?
wait a minute. You can, but don't tell me. 30, 5 to square. Ah, that's 20. This is 3, 6. Okay. So 30, 20, 10, 16, 15 is pi. That sounds better.
1 second. Yeah.
And these are not going to cancel each other out because of that minus the whole mess. If you cancel each other out, you're going to end up with 0. That would be bad because you know the volume of that is not 0. Now, we didn't really think about what the shape of this looked like, so you know it can be done without thinking about it. It might be helpful if you think, all right, what does this look like when it's rotated? It kind of looks like it'll do this business. Yes. Okay.
Oh, okay. I was trying to rotate it the other way.
And rotate it about the y-axis, that red line there. Okay. Any comments on that problem? Okay. All right. Let's try. This is just the generic information that we've been talking about. Pi r squared, r is your radius. Go from A to B. All right, this is in terms of x. If you do in terms of y, you got to do r of y.
Sweet, it is.
Yeah, it's bizarre, yeah.
Why would you do that?
Okay.
That's real dumb.
Radii in the disk method is perpendicular to the axis of rotation. That's the biggest thing
That's
to remember.
tricky.
All right, let's try this one. There will be some that you have to do by hand, so don't, like, I wouldn't expect you to graph this by hand, so if I don't expect you to graph by hand, that means you can do the integral with the calculator as well. But don't get, like, so dependent on the calculator with your integration that you are like, oh, I forgot all my methods of integration. You spent like a whole semester on that. Please don't forget it. Okay. So area equals, that's blue. It's got to be the curve right here. Okay, x equals 0. Where's x equals 0? The y-axis. Okay. And then y equals 2 is the red one, right? Okay.
So we're assuming we're doing the positive side?
It doesn't matter because they're the same.
Okay.
It doesn't matter because they're the same, but good question. Yeah. So we'll do one. You can do both. I'd rather deal with a positive number than a negative number any day, so I'm going to do the positive side. But these two are symmetrical. They're both the same, so you want to do the negative side. Okay. Volume of disk. Pi r squared h. All right, draw your axis. We're going to rotate it about the y-axis. So we're going this way.
So are we doing horizontal?
Are we? Because we have to have the radius. Where is the radius going to be? Perpendicular to the y-axis. So, yes, we are going to go horizontally. Okay, which is in terms of what? Y, because we're hitting the y-axis eventually, if not right away. Okay, the radius actually is sitting on the y-axis. Okay, yes. So, what's my radius? This is what it looks like. It's in terms of y.
You're going to make it
2.
No, why did the 3 have?
Blue is on the right. Say again.
Why did the 3 have?
Y to 3 halves minus 0 is
Squares.
That's the
When you
radius.
put it in.
Yeah. What, Emma? You good? Okay. Let me simplify this. It's y to the 3 halves. When you said something about 2 minus, you were going the wrong way. You were going this way. That's why we need that visual. Okay, so that is y to the 3 halves. I already got the squared. Change in y. Did I lose anybody? All right. What's my integration? What's y to the 3 halves squared? Y to the what? Third. I'd rather put, even if I'm going to do my calculator, I'd rather put y to the third than y to the 3 halves squared in the dy. I'm not going to put this in my calculator anyway. This will be an easy one. What are my limits of my y's? 0 to 2. There's your 2, Hannah. Okay? Is that at the top? Y. That'd be very visual. Y is up and down. All right, go for it.
You identified as setting y to the 3 cups.
No, I knew it was 2 up here,
Oh, because it,
because this is the equation y is 2, so.
okay.
But you could, well, no, that's if you wanted x.
No, we didn't do it. Perfect.
Get it?
We ended, like, we have 2 minutes to lunch, a minute.
Perfect.
Way to go, Lauren. Finish recording, stop the recording.
I don't have any more, okay.
That's a bed.
All right.